Hi there, as a part of AgilePoint's version 10 release, we're happy to announce support for Nvidia NIM. Now, like most other AI platforms, support for NIM includes both process activities, which we've covered in a prior video, and AI control towers, which we'll focus on today. Now, in addition, if you'd like to learn how to connect to NIM, please do watch the companion video. Okay, so moving into our application designer, again, we're using an insurance claim application as our demo app. We'll walk through the configuration here in just a moment, but as you're seeing here, I have the Nvidia NIM activity group open under the Control Towers tab. Now, like the other AI platforms supported in AgilePoint version 10, at a high level, we have a control tower for analyzing an image and using chat completion, where we just want to get the response. But in each of these, there are subcategories to bring in dynamic process behavior. So as an example, analyze an image and adapt the flow, inject ad hoc tasks, initiate sub-processes, which you'll see here, and send a notification. And the same activities also are included under chat completion. So as you're seeing here, we have 3 NIM agents across the top, and we'll walk through the configuration in just a moment. But what you're seeing here are fairly typical insurance claim processing steps, where the process will start when a customer has had an accident and will call into the call center to relay initial details about that accident and open up a new claim. From there, the process flows externally back to the customer, where they can provide a more detailed narrative around the accident and supply any images showing damage to their vehicle. Now from there, we have a number of internal steps, which we won't cover as a part of this video. But turning our attention back to the top, again, we have 3 Nvidia NIM agents. 1, to analyze the image provided by the customer showing damage to the vehicle, and returning a damage assessment, essentially which parts of the vehicle were damaged. These insights will be handed over to our claims analyzer agent to essentially make a comparison. How does the output of our image classifier line up with the narrative of the accident provided by the customer? And then finally, our fraud predictive agent, receiving the insights from the prior 2, will make an overall assessment looking at the totality of the claim. In this case, with this context, how likely is fraud in this claim? Now, if fraud is likely, we're going to see this agent stop the typical processing and inject additional levels of review for our investigator team. So let's go take a look at the agent configuration. So first, as you're seeing here, we're using a control tower to analyze an image. So that image will be uploaded to an AgilePoint form and in turn move to one of the out-of-the-box repositories supported by AgilePoint. In this case here, we're using Box. I've selected my access token, specified the model and initial model parameters. But moving into the system instructions, we're going to see a very structured and bounded experience, helping me get that prompt just right compared to the sort of free-form text you might be used to in traditional prompt engineering approaches. So the goals and mission are to analyze an image showing a vehicle that's been in an accident and returning a structured damage assessment. The skills include computer vision, damage detection, visual inspection, and JSON formatting. The input is going to be the image as provided by the customer. Various instructions, including that structured damage assessment. Essentially, there are 9 parts of the vehicle. We'd like to determine whether each part has been damaged. And as you're seeing here, various rules, most importantly, basing the analysis strictly on what's visible in that image. Now you're seeing here various quality verification steps. And then finally, the output here being a JSON structure that we'll use later on in our application. Now here you're seeing triggering event. Again, one of the big differences in the control tower is that event-based framework. So this agent will trigger when the customer engagement step has been completed, but I could bring in additional filter conditions. Now the request is blank. Again, this is going to come from the customer uploaded to our form. And the response here again is a JSON structure that I'm mapping back to my application schema. No parsing required in this case. If I did store the response in a variable, there are different ways I can parse it. And nothing here from an actions perspective. We just want to get the response back from that model. Now of the remaining 2, they're very similar in terms of configuration. However, the fraud predictive agent does bring in dynamic behavior. So let's take a look at that. So again, connecting into NIM, the model I'd like to use, initial parameters, And let's move into the system instructions. So here we're looking at the totality of the claim. So we're analyzing the claim as a whole to look for indicators of fraud, anomalies, inconsistencies, unusual patterns, things like that. The skills include insurance domain understanding, fraud pattern detection, various types of analysis, and rules-based, clear, explainable reasoning. The input here is that JSON structure, various instructions, how to analyze the claim, quality verification. Now in this case here, we're looking at an overall assessment. Is fraud likely in this claim or not? Again, our triggering event is when the wait for milestone activity has been completed. In the request, the JSON structure has been intelligently brought over from my system instructions, which leaves me with a very straightforward mapping. Now from a response perspective, we want a fraud assessment and a probability. So we're bringing that back from our model, mapping that to our application. Again, no parsing required. But here under actions, we're bringing guardrails and governance as to how AI can impact my process. So if fraud is likely, we're going to bring in a sub-process that provides additional levels of review for our investigators. But you're seeing here additional rules as to how we prescribe that. So in the event that fraud is likely and the probability is greater than 50%, or if there are inconsistencies in the report as provided by the customer, go ahead and invoke that sub-process. Okay, so we're going to go ahead and run the application. So moving into my form, I'm going to play the role of the call center employee. A customer has just had an accident and I want to retrieve details about their policy. We'll select the vehicle involved, the driver's name, capture initial details about the accident, the third party involved, prior claim history, and lastly, we'll leave a comment and open up the new claim. Okay, so our process is now running. Let's go ahead and track it. All right, so we're now sitting with the customer engagement step. So I'm going to switch roles to that of the customer and provide more detailed accident narrative and upload an image showing the damage to my vehicle. Okay, so here's the image I'll be uploading. Pretty clear damage to the front of my vehicle. Okay, so while that's uploading, at the bottom, we have more detailed accident narrative. So what I'd like to do here is just introduce some key conflict between what's shown in the image and the description. So I'm going to remove the front left side and indicate the back of my vehicle was damaged. Okay, so we'll see indicators for each of the agents as they're invoked. Okay, so each of our agents have run. Moving back into our task list, we're going to see here that the typical next step in our process would be with the claims handler. Now in this case here, when I try to open this, I'm going to be met with a warning indicating that fraud is likely in this claim and that the typical processing has been paused. So you're seeing here, that message is now showing. Now as a subject matter expert, I've just been routed a task to review the claim. All right, so as you're seeing here, the AI control tower has brought a human into the loop to validate all of the insights. So starting with the output of our vision model, as you can see here, the front of the vehicle has been damaged. Our claims analyzer agent has determined this is a human authentic report, but that fraud is likely due to key conflicts in the narrative. And then lastly, moving over to the adaptation screen, here I can determine how to move forward and whether I'd like to take the suggestion from the AI control tower. So as you can see here, it's suggesting I inject a step for the investigation team. So I'll go ahead and assign that to myself. And I want to keep the lock on all of the downstream steps until that investigation is completed. Okay, so behind the scenes, AgilePoint's engine is now injecting an additional step into this process. And you're seeing that task here. So now, as the investigator, I can still review all of the AI insights. Again, vision model, claims analyzer agent, and the overall assessment. So here I'll take an offline action to validate the fire and police reports and determine how the claim goes forward. Now, using my expertise, I can determine that in this case, no fraud, it's just a customer who's a little bit frazzled after having had an accident. So I'll release the lock and resume the normal processing. Now in closing, there are different ways we can observe and monitor agent behavior. Clicking into any one of our agents, we can see all of the details, including the input and output parameters. So those details will always be available in the process viewer, but bear in mind that AgilePoint has a dedicated audit trail for any AI control tower actions within the Manage module. So you're seeing here, I have a tab for AI control towers, where again, I can review all of the inputs, outputs, and actions any agent might have had. So let's look at our fraud predictive agent here as an example. We can see what's triggered this agent, again, the input and output parameters, which we can use for ongoing compliance or model retraining purposes. Okay, so with that, that's going to conclude the content for this video. Thank you so much for watching. We'll see you soon.